Hello dear students. This video lesson is a review of important theorems from the chapter Circle. These theorems have already been done in the previous video lessons. But considering the importance of this chapter Circle, I am discussing these theorems once again. I want you to make a note of all the important theorems. There are many theorems in the textbook, but which all theorems you need to learn to prove. And there are some theorems where if you just learn the statement or just understand the statement, that is more than enough. So this is a very important video lesson where I will be revising all the important theorems once again. Please have a look. Now this was already shown to you in the previous video lesson. There are 5 important theorems that you need to learn to prove. In the textbook, no doubt there are many theorems, but these 5 are the ones that you need to know how to prove them. And the ones with a star are these 2 theorems, which are extremely important. Now let us discuss them one by one. And along with the theorem, the next slide will be a problem pertaining to that theorem. So you will know how to apply that theorem in problems. Let us have a look at it. Now, this is theorem 10.1. In the textbook also it is given as theorem number 10.1, which states equal chords of a circle subtend equal angles at the center. So when a statement like this is mentioned, you have to prove it. So in order to prove it, you have to first draw the diagram and then write down what is given and what you need to prove. Equal chords of a circle. So draw 2 chords of a circle. Anywhere on this circle, you will take 2 chords. I've taken chord AB and chord CD. These 2 chords are of equal length. Now, what you have to prove? You have to prove that they subtend, they form equal angles at the center. So this is the center O. I have drawn an angle here BOA, and another angle is formed here, that is angle DOC. You have to prove these 2 angles are congruent. So once the diagram is drawn, write down what is given and mention what you need to prove. And then you begin with the proof. Take the 2 triangles, write down what is mentioned or what is given. You know that chord AB is congruent to chord CD, so it is given. Then take the radii of the circles. So radius OB of this triangle, okay? Now radius OB is congruent to radius OD because they are the radii of the same circle. Then radius OA is equal to radius OC. OA and OC, same indication is given, they are also equal because they are also radii of the same circle. Now the 3 sides of one triangle are congruent to the corresponding 3 sides of another triangle. Therefore, the 2 triangles will be congruent by SSS test. And students, these tests of congruency you have already learned in grade 7. Now, the 2 triangles are congruent by SSS test. Therefore, angle AOB is congruent to angle COD because they are the corresponding parts of congruent triangles. What does that mean? When the 2 triangles are congruent, all the remaining parts will automatically be congruent. That means the remaining angles, the corresponding angles will be congruent, the corresponding, well, sides are not here because we have taken all the 3 sides. So all the corresponding angles will be congruent. Now, how do you apply this in problems? What kind of problems you could get pertaining to this theorem? Let us have a look at it. In a circle with center O, there are 2 chords PQ and ST, and they are congruent to each other. So I want you to draw a diagram, a rough figure, draw a circle, take the center of the circle as O and draw two chords which are congruent. If the measure of this angle is 130 degree, it will be the angle at the center. It is 130 degree. What will be the measure of angle POQ? Measure angle POQ will also be 130 degree. And why is that so? Because you've just learned congruent chords. They subtend congruent angles at the center. So if the two chords are congruent, then the angles that they form will also be equal. Now look at this. Chord AB and chord CD both are congruent. Mentioned either CD or DC. You have to find out the measure of angle DOC if this angle is 110. So if angle AOB is 110, angle DOC will also be 110. Why? Congruent chords, they make congruent angles at the center. So that is the reason for it. The reason will be the statement of the theorem. So I hope you have understood the theorem and how to use that in problems. Now let us look at another theorem, the converse of that theorem, that is theorem number 10.2. Now theorem 10.2. If the angles subtended by the chords of a circle at the center are equal, then the chords are equal. What does that mean? In this given circle, there are two chords AB and CD, and they are forming equal angles at the center. That means this angle AOB is equal to angle DOC. Okay, so that is given, and you have to prove AB and chord CD are equal. So isn't this the reverse of theorem 10.1? So it is called as the converse of theorem 10.1. So this is theorem 10.2, converse of theorem 10.1. So proof. Again, you have to take the two triangles, mention what is given. Now it is given that the two angles are congruent. So I have written out here given. Take the radii of the circles. OB of this triangle is congruent to OC of this triangle, and they are the radii of the same circle. Similarly, OA of this triangle is congruent to OD of this triangle. And why they are congruent? Because they are the radii of the same circle. Therefore, the two triangles become congruent by SAS. This is a test of congruency. And the two triangles are congruent, then the corresponding parts or the corresponding sides or the corresponding angles will also be congruent. So chord AB will therefore be congruent to chord CD because they're the corresponding parts of congruent triangles. This is what we need to prove. So that is why I've taken chord AB congruent to chord CD. This angle will also be congruent to this. This angle will also be congruent to this, but that is not what is asked. They have asked you to prove the chords equal, and that is what I have proved, chord AB congruent to chord CD. So this is theorem 10.2. Now what kind of questions you could get pertaining to this theorem? Let us have a look. Again, please sit with a book and a pen and try to get the answer on your own. They have given a circle with center O, diagram is not drawn. If O is the center, doesn't this and this angle become the central angle? That means the angles subtended at the center are equal. And one of the chord is 7 centimeters. So what will be the length of the other chord? Now, how do you find the length of the other chord? It will be the same. It will be 7 centimeters. Why will it be 7? Chords which subtend equal angles at the center will be congruent. So if the angles at the center are equal, then the chords will also be of equal length. Now, this is also similar type. They have mentioned that this angle is 110 and this angle is 110. And if chord AB is 6, what will be chord CD? CD will also be 6 centimeter because chords which subtend congruent angles at the center will be congruent. The two chords will automatically be equal. So it is that simple. Okay, you just have to remember the statement. Of course, the theorem, these two theorems are important. You need to know how to prove them, and you could get questions like these in the exam. Now let us look at another theorem, that is theorem 10.3. Now, very, very important theorem. The perpendicular from the center of the circle to the chord bisects the chord. So this is the diagram where OM is perpendicular to chord AB. So that is what is given. You have to prove that it bisects the chord. So to prove, seg AM is congruent to seg BM, because this line is cutting this chord into two equal parts. So you have to prove AM is equal to BM. So let's see the proof. You have to take the two triangles, OMA and OMB, prove the two triangles are congruent. Now each is 90. If this is 90, obviously this is also 90. Then OM is congruent to OM. It's a common side. Now, if you look at these two triangles, they are right angle triangles. So what does OA and OB become? Are they not the sides opposite to the right angle? So they are the hypotenuse of the triangle. Okay. So hypo OA is congruent to hypo OB. You can use the short form hypo. Why are they congruent? Because they are also the radii of the circle. So they are equal. Now, if you look at the test, if the hypotenuse is equal, and if one of the perpendicular side is equal, then the two triangle becomes congruent by RHS congruence rule, that is right hypotenuse side rule. So this is again an important test of congruency. RHS, you use it only when the triangle is a right angle triangle and the hypotenuse should be congruent and any one of the perpendicular side should be congruent. Then the two triangles become congruent by RHS rule. So now let's find out what is CPCT in this. Therefore, AM is equal to BM because they are the corresponding parts of congruent triangles. Students, I want you to learn how to prove this, a very, very important theorem. The perpendicular from the center of the circle to the chord bisects the chord. Let us look into what kind of question you could get pertaining to this theorem. In a circle with center O, OM is perpendicular to chord AB and the length of the chord AB is 12. You have to find length AM. I've already given the answer here, 6 centimeters. See if you can work it out and get this answer. So diagram is not required. Nevertheless, I've just drawn it for better understanding. OM is perpendicular to AB. AB is a chord. This entire AB is 12. They've asked you to find out AM. Use the theorem. Any perpendicular which is drawn from the center of the circle to the chord, what does it do to the chord? It bisects the chord. So if this entire thing is 12, AM will be half of 12. So AM will be 6 and BM will be 6. And what is the reason? Reason is the statement of the theorem. That is, the perpendicular from the center of the circle to the chord bisects the chord. Now, this is another question. OH is perpendicular to BD and BH is given as 5. So if BH is 5, what will be HD? HD will also be 5 because the perpendicular is bisecting the chord. And if HD is 5, what will be the whole thing BD? It will be equal to 10 centimeter. So students, this was theorem 10.3, a very important theorem. I want you to learn theorem 10.1, theorem 10.2, and this theorem 10.3. In the next video lesson, we will be revising few more important theorems that you need to learn how to prove. Until then, goodbye and take care. Thank you.